This is Geometry Homework 7-3 Multi-Step Pythagorean Theorem. So in this worksheet, it's kind of interesting because the instructions tell us, yes, we're finding the area just like we did in class, but it tells us that intermediate values should be rounded. And then we use the rounded values to calculate the next value and the next value. And what usually happens there is you get more and more and more error until the very last answer has like a ton of error, which will match the back answer. But that isn't how life works. You don't just accept the fact that you're gonna make a bunch of errors, and I'm not going to accept those answers. So yes, you can follow the steps and see what the actual answer is gonna be. I'm going to compare my answer, and it'll be a little bit off. Maybe it'll be like a 19.6 instead of a 19.8 to make sure that I'm roughly in the right area. But other than that, I'm going to keep my answers as exact as possible until the very end. And then at the very end, I will round to the nearest tenth. And that's I'm hoping that's what you do as well. So let's go ahead and try to do number one. And I have this calculator open to left because you will be using it to find what the square root values are approximately. In order to find area for any single triangle, we're always going to be using this area formula, where area is equal to the base of the triangle times the height of the triangle, which would normally be a rectangle right here. So if I just do base times height, we get the area. But because it's a triangle, we cut that in half, and I'm only talking about this half, so we need to cut that area in half. And there's our formula. So we have the height. That's going to be h. I'll label that. H is equal to 9. We do not have the base, b, down here. So I need to find the base. And I use Pythagorean theorem. In general, if I have a right triangle and I'm trying to find one side length when given two other side lengths, you will use Pythagorean theorem. I know that feels weird for me to say that, knowing that you said it's Pythagorean theorem, but on the final, on other things in life, you might not know when Pythagorean theorem will apply. So let's go ahead and set up our a squared plus b squared is equal to c squared. Again, c is always opposite of the 90-degree angle, opposite of that right angle. So c is going to be 10. And I'm going to fill in everything else as well. I'm going to have a 9 squared plus b squared. All right, and I'm trying to make my b's look different than my sixes. My sixes will be rounded and my b's will be straight. All right, so my 9 squared is 81 plus b squared is going to be 100. And then from here, I'm going to subtract 81, and those are gone, giving me b squared is equal to 19. And then finally, I'm going to square root to get the b by itself, and I get b is equal to the square root of 19. And I'm essentially done. I can plug that in. I can say, okay, our area base was the square root of 19. The height was 9, and I'm going to divide all of that by 2. I can punch that into my calculator. I can say the square root of 19 times 9 times 9. And a lot of people were frustrated. They said, when I hit divide by 2, it only does one of them. Here's the thing. It doesn't matter. But if you really want it to look the same, you can put parentheses. If I just hit the right parentheses, it'll put a parentheses and invisible parentheses on the left, and then I can hit divide by 2, and all of it will be over 2. You can see that answer, and if I just do the square root of 19, and then out here times 9 divided by 2, it doesn't matter the order in which I do things. It'll still work whenever you have multiplication and division, because in terms of PEMDAS, those are at the same rung, and they shouldn't affect your answer. But either way, our answer here is about 19 this was about 19.615, which gets rounded to 19.6, which I will have for my final answer, which will not match the back. I don't think any of these will match the back. 19.6 for my answer, and they got a 19.8. So we are in the ballpark, which I'm going to give myself credit for. All right, I want to start moving through these a little bit faster, not explain them as deeply. I know that I need to find the height here. Therefore, I'm going to do height squared plus 8 squared is equal to 12 squared. And it's going to be 64 is equal to 144. Don't forget to have the height squared as well. I'm going to subtract 64. This is going to be height squared. Those are gone, is equal to, that's going to be 8 with a 0. And then I'm going to take the square root, and I'm going to get h is equal to the square root of 80, because I'm taking the square root of each of those. And you might be tempted to say, well, I can simplify that square root. It doesn't matter for this lesson. It doesn't matter that we do a factor tree and say, oh, well, that's technically the square root of 4 and square root of 20, and that's the square root of 4 and the square root of 5. So this is really 4 times root 5. Yes, you're good at doing that, guys, and thank you. But we don't need to do it for this problem because we're going to let the calculator handle it at the very end anyway. Again, we're using the fact that area is equal to base times height, divide by 2. So I'm going to say base times height divided by 2. And I'm going to punch that into the calculator. I'm going to say 8 times the square root of 80, and then all that divided by 2. Again, it doesn't matter the order in which I do that. And I get, this is approximately, I'm going to round at the same time. This is going to be 35.8 because the 7 is going to be rounded to an 8. And as long as I'm in the ballpark, I'm good. 35.8, 35.6, I was in the ballpark. Okay. In number 3, we need to find the height here because we don't have that. We do have the base, but we do not have this height. So to find that, I'm going to break this into, I'm just going to look at the right triangle, the right side of the triangle over here. That's going to be 8 and 5. That's the key part. I'm dividing 10 in half. I'm allowed to do that because both of these sides are the same. Therefore, this is an isosceles triangle. If I cut this in half, I know this is exactly 5. Some people might say, well, is this 4 and 6? How do you know? Because this might have been like, what if this had been a 5? Then we wouldn't know. This probably would have been smaller. In fact, I'll talk about in a future lesson how it is smaller. But because these numbers are the same, these get split exactly in half and we get 5 and 5. So from here, I'm using Pythagorean theorem in order to figure out what my height is. So I'm going to say h squared plus 5 squared is equal to 8 squared, and that's going to be h squared plus 25 is equal to 64. If I subtract 25 on each side, subtract 25 on each side, I get h squared is equal to 39, I believe. I think that's right. Yeah, 39, and then I'm going to square root, and I get h is equal to the square root of 39. Plugging it into our area formula, area is base, which we know is 10, times the height, which we just figured out is the square root of 39. That's all going to be divided by 2, which is going to be approximately what? It's going to be 10 times the square root of 39, and that's all going to be divided by 2. So I'm going to get about 31.2, which is going to be my final answer. I'm guessing the backs are going to be like 31.4 or something. I don't know. Oh, it was just 31. So I'm off by like 0.2 on almost all of these. But I was in the ballpark, so I'll give myself credit. All right. We need a base and we need a height for every one of these problems. We have a height, check. We have a base, we have a piece of a base. We're missing u. So as long as we can find, I'm going to call this length right here, let's call that x. If we can find x, I can add it, this number plus this number to find the entire base. So let's go ahead and purely analyze the triangle over here on the left. It's that right triangle. That's supposed to be a right triangle where we have a 3 and a 6 and an x. So I'm going to say that x squared plus 3 squared is going to equal 6 squared. Therefore, x squared plus 9 is equal to 36. Then I'm going to subtract 9 to get x squared is equal to, doing this in the wrong direction, it's going to be 27. And then from there, I'm going to square root everything, square root, and x is equal to the square root of 27. All right, so to find the base is going to be adding this number and this number. It's going to be adding the root 27 plus 3. So the base is going to be the square root of 27 plus 3. And I can estimate that now, or I could just plug that in. I'm going to just plug it in because that's the type of person I am. I don't like any error at all. So I'm going to say that my area here precisely is going to be the base, which is going to be the square root of 27 plus 3. That entire number is the base. Then I'm going to multiply by the height, which we already knew was 3. Again, this height right here is 3. And then I'm going to divide that by 2. And if I do that on the calculator, I need to make sure I have my parentheses correct. So I have parentheses, and then I'm going to do square root of 27, and then plus 3. And that's going to be multiplied by 3, and then I'm going to divide that by 2. It doesn't matter the order, and I'm going to get this answer of 12.29, which is 12.3. I'm going to guess 12.1 for the back side. Let's see. 12.3. We actually got one correct. Exactly on the money. Good for us. All right, we're doing number 5. Again, what we need to solve every single area triangle problem, we need base and we need a height. We have the height, it's 3. We don't know the base at all. So I'm going to have to do 2 different problems here. I'm going to first analyze this triangle on the left. I'm going to call this x. I'm going to call this y, I guess. And we're going to solve for each of these. So notice that I have leg, hypotenuse. So I'm going to have x squared plus 3 squared is equal to 4 squared. x squared plus 9 is equal to 16. Subtracting 9 to get x squared is equal to 7. And then I'm going to square root and square root to get x is equal to square root of 7. Done. Now I'm going to try to figure out y. Notice I have 1, 2, 3 values. 2 of them we know, 1 of them we don't, which is a sign that we're going to be using Pythagorean theorem with this right triangle. So I'm going to say leg squared plus leg squared is equal to the hypotenuse squared, and solve. I have 9 plus y squared is equal to 49. From there I'm going to subtract 9 to get y squared is equal to 40. And then I'm going to square root to get the y by itself, giving us y is equal to the square root of 40. All right, so we have a height, it's 3. We have a base, and the base in this problem is the square root of 7 plus the square root of 40. Some people might think that that is the square root of 47. That is not equal to the square root of 47. Be careful, because I will show you, I'll prove it to you. Watch this, with a calculator. The square root of 7 plus the square root of 40, square root of 40 is that number, and the square root of 47 is that number. These two numbers are not the same. One is 8.97, the other one is 6.86. So I'm going to take that as my base, and I'm going to say my area formula, area is going to be base, which is square root of 7 plus square root of 40. That's my base, and I'm going to multiply it by the height. Height is 3, and I'm going to divide all of that by 2. I'm going to punch this into my calculator. So here's a cool little shortcut that you can do. You can put all of this in parentheses, and then multiply by 3, and then divide it by 2, and we get 13.45, which is going to round to 13.5 for my final answer, which I will then box. All right, so let's see how the back does. In number 5, I got 13.5. In number 5, I got 13.4. Really close. We know we're in the ballpark. We have an exact answer. Well, we rounded the nearest 10th, but we didn't round until the very end. So kudos to us. Number 6 is going to be the exact same type of problem. I am missing u and u for the base, so let's go ahead and call this one x, call this one y, and figure out what these are. So notice that I'm going to be talking about this triangle that is a right triangle first, leg, hypotenuse, so I'm going to do leg squared plus leg squared is equal to hypotenuse squared. X squared plus 25 is equal to 36. I'm going to subtract 25 on both sides, giving me x squared is equal to 11, and then finally I'm going to square root, and I get x is equal to the square root of 11. Time to solve for y. I have a right triangle right here. I have a leg, and a hypotenuse, so I'm going to do leg squared plus leg squared is equal to hypotenuse squared. So y squared is going to be added to 25, and that's going to equal 49. Let's go ahead and subtract 25 on both sides, y squared therefore will be equal to 24, and then from there I'm going to square root both sides, giving us y is equal to the square root of 24. So we have our base. The base, we add x and y together. We add square root of 11 and the square root of 24. So that means that my area of my triangle is base, which is square root of 11 plus the square root of 24. There's my base. I'm going to multiply it by the height. The height here is 5 because there's our height. And I'm going to divide all of that by 2. Do I have any room over here? I do. My answer will go right over here. Let me type it in the calculator. I have the square root of 11 plus the square root of 24, and all of that in parentheses divided by 2. Oh, and then I need to multiply by 5. Haha, I forgot that bit. Times 5, and I get 20.54, so it's just going to be 20.5. 20.5, and I will box that. And technically, I don't have this exactly equal to. I have approximated now, so I'm going to change this equal to sign into the wavy equal to sign, which means I have approximated. Have I been doing that? I can say that this is approximately, and approximately. Now I've used that approximate sign. 20.5 for number 6, and I check. Number 6, ooh, I actually got it on the nose, 20.5. All right, then we do number 7. Again, we need a base and a height. We're missing both. I don't know that, and I don't know that. I know that this is going to be the height. I'm going to call it h. I'm going to call this, I don't want to call it the base because that will be confusing. The base is 10 plus this number, so that intermediate step, we'll just call that x. It might be, a good idea to do this triangle first, but I think that would be bad because I would have a variable, and a number. I need two numbers in one variable. If I do this left triangle first, that's better because I have two numbers in one variable. Let's go ahead and set up that left triangle. I have a leg squared plus the other leg, which is the height squared, and that's going to be equal to the hypotenuse, 13 squared. So it's going to be 100 plus h squared is equal to 169. I'm going to subtract 100, and h squared is equal to 69. From here, I'm going to square root both sides, giving us h is equal to the square root of 69, and we're done with h. Now, h is a number. It is the square root of 69. I have a number, and a variable. I'm ready for Pythagorean theorem over here. So remember that this is the square root of 69, and that leg, square root of 69, will be squared. I'm going to add it to the other leg, x squared, and that's going to be equal to the hypotenuse, 10 squared. Notice that the square root and square do cancel each other up because they are inverse operations. So I have 69 plus x squared equal to 100. From here, I'm going to subtract 69, and I have x squared equal 31. From here, I'm going to square root, and get x is equal to the square root of 31. All right, it's time to actually calculate what our base is. So we know that our base is going to be equal to this value and this value, not multiplied, but added. 10 plus x, and x is root 31. So this is really 10 plus the square root of 31. A lot of people will try to punch this into the calculator now. I don't punch it into the calculator until the very end. So here is our area. Our area is going to be the base, which we just found was 10 plus square root of 31. I'm going to multiply that by the height, which we discovered was the square root of 69. Times the square root of 69, and I divide base and height by 2. This will be approximately what? Punch it into the calculator. Ready, set. It's going to be in parentheses 10 plus the square root of 31, and that's going to be multiplied by the square root of 69, and then all of that is divided by 2. And the answer here is going to be 64.6577, which rounds to 64.7. Final answer and box it. Were we close? 64.7 to the back. 64.7. Ooh, we got that one on the nose. All right. And then last problem, number 8. Again, we need a base and we need a height. We have a base and a base that is missing, but we do have a height. So I'm going to call this side x, this side y, and we'll solve. I'm going to first use this triangle. Notice that we have a number variable, so that's ready to go, and I have a number variable. It doesn't matter which side I choose first. I'm going to do leg squared plus leg squared equal to hypotenuse squared. So this is going to be x squared plus 25 is equal to 100. We'll subtract 25 from both sides, minus 25, and that's going to give me x squared is equal to 75. I then square root both sides, and x is equal to the square root of 75. For my next triangle, I'm going to do leg squared plus leg squared is equal to hypotenuse squared. Give me y squared plus 25 is equal to 49. From there, I will subtract 25, and y squared is equal to 24. When we square root both sides, we get y is equal to the square root of 24, and we're ready to calculate what our base is. The base is adding this length and this length, x and y. X is root 75, y is root 24, so the base is root 75 plus root 24. I'm not going to evaluate that. I'm going to leave it until the very end and calculate our area. Our area is always going to be base, which in this case, in parentheses, is root 75 plus root 24. That base times the height of 5, all divided by 2, will be the area, and we will find that approximate value when we plug it into our calculator. Starting our parentheses, we have the square root of 75, and then it's going to be added to the square root of 24, and that's going to be multiplied by 5 and then divided by 2. And that is approximately 33.89, which is going to round to 33.9 for our final answer, which we'll then box. Let's check to see how close that was to the actual answer. 33.9 is very close to 34, so I think I've got it. And that concludes worksheet or homework 7-3 for geometry. Thanks for watching.